Okay, let's take the first one. Fracking for gas development is a 60-year-old well-proven technology. That is, as it's written, a true statement. Fracking was indeed invented in the late 1940s. It has indeed been used on over 1 million oil and gas wells alone in the United States. It's well proven. What kind of fracking is used for unconventional gas development in shales? Is it the kind that's been used for 60 years and over 1 million wells, or is it the kind that's been used for about a decade on 20,000 wells? Ooh, we just morphed from truth to myth. We have expanded what is basically a true statement to imply to the uninformed, and you are no longer uninformed, that you can extrapolate from the past and apply it to the present. That's what myths do. So let's see why the current kind of high volume slick water hydraulic fracturing and long laterals is not your grandmother's fracking. It's not because it requires 4 technologies, we'll count them, I'll point out each one of them, that needed to be invented over the last few decades and needed to be coalesced, brought together, combined in a very unique way through a series of experiments that occurred in the 1990s and were perfected in 2007. So those 4 technologies: drilling, you all know what that means. Well can go down here. Here's a picture. The well can go down vertically like all conventional wells or most conventional wells, and then can be turned and propagated in any direction for basically any length that you can technologically achieve and you're willing to pay for. So directional drilling had to exist in order to access an unconventional source such as shale, because obviously the shale is a few hundred feet thick and you're thousands of feet down, and if you only drill vertically into it, you don't get very much exposure in your well. But if you can turn more or less laterally, more or less horizontally, and have a long lateral, you can expose your well to miles of shale. That technology had to be invented, and it was invented in the 1970s, perfected in the 1980s, 1990s. But because they can now directionally drill, and they can make this lateral be miles long, another technology had to come along, and that's the ability to inject very high volumes of frac fluid. All right, so here's another question. Remember now, you're above average, so I expect above average performance here. What is the typical volume of frac fluid injected in a conventional gas well? I'm going to give you a multiple choice answer here. Ready? A, none. Anybody choose A? No, okay. Tens of thousands of gallons, hundreds of thousands of gallons, or millions of gallons. Conventional well, tens of thousands, hundreds of thousands, millions. Tens of thousands. Conventional well, your grandmother's gas well. The thousands of gas wells that already exist in Pennsylvania and New York that are conventional, tens of thousands of gallons. In New York, there's a legal limit. In New York right now, a gas company cannot hydraulically frack a gas well or an oil well using more than 80,000 gallons of frac fluid. Roughly 10 truckloads. Okay. So how much is the average frac load in an unconventional well in the Marcellus in Pennsylvania? 5.5 million gallons. How much more than 80,000 is 5.5 million? A lot. Thank you. Okay. Now you're on track. So somebody had to invent a means of getting all that fluid down 2 or 3 miles of, what's the diameter of the production casing? This is a basic test to see how much you've learned in the last couple of years. You know, I can't tell you everything tonight. I'm expecting that you already know things. What's the diameter, typical diameter of the production casing? The steel pipe through its gas comes up. 1 inch, 4 inches, 10 inches, really big. More like 5 or 6 inches. It depends, okay? Sometimes 7, but okay. So now you want to force 5.5 million gallons of fluid, say 500,000 gallons at a time, because there are various frac stages. 500,000 gallons, 2 to 3 miles through a pipe that big at 10,000 pounds per square inch. Now you got another problem. Too much friction in the water. How do you lubricate water? It's not a joke. You make it slick. You add chemicals to it. That's where the word slick water comes from. I bet you thought the word slick came from somebody in Texas. No, wrong. Well, it did come from somebody in Texas, but the idea is to add a chemical to water to reduce the friction as the water, which is now no longer water, it's water plus chemicals and sand, is pumped at very high pressure over a very short period of time, on the order of an hour, a couple of miles through a very small diameter pipe. So that's another technology that had to be invented, slick water. And finally, the last component that was the last piece of the magic sauce to make this all economically viable is we don't have to just drill one well here and then go over there and mine. We can from one pad because of directional drilling and because we can bring all that heavy equipment to one spot at one time and decrease our cost by drilling multiple wells without having to move the big rig, and we can frack all those wells without having to move all the frack equipment. We can drill 6, 7, 8, 9, 10, 12, 16 wells from one pad. Okay? So those 4 technologies had to be invented in response to the geology. And this is a photograph that my colleague Terry Engelder, you probably know who he is, gave me some time back. It's a photograph that he took in a gorge near my house. This is a gorge in upstate New York, and what we're looking at here is an exposed layer of black shale. It's not Marcellus, but it's a black shale. And all these nearly perfect straight lines, what are those called? Joints. Okay, what's a joint? It's a natural fracture in the rock. Okay, they're already there. Black shales, shales that are being developed for gas, are already naturally fractured. If they weren't, it would not be possible to economically develop gas from them. These joints become the natural pathways that are re-stimulated by refracturing them by hydraulic refracturing. So another myth is that when we fracture the rock down there, we send, and this is a myth that comes from the opposite end of the spectrum, the eco-freaks, the crazies who don't know what they're talking about. Yeah, we blast high volumes of fluid into the rock to pulverize the shale so that the gas comes out. Nonsense. What we're really doing is, there's your lateral, the red line, and remember that lateral is a couple miles long, so how many of these joints is it intersecting? The average joint spacing is about a yard. So over 2 miles, you're intersecting thousands of joints. And what you're trying to do is reopen those joints by pumping hydraulic fracturing fluid into them at a pressure sufficient to overcome the pressures that are down there on the order of 10,000 pounds per square inch, depending upon height. And those joints are now reopened and they become super highways for gas. Shale as a rock is very impermeable. It doesn't want to have fluids flow through it very easily, but the joints are super highways. If we can open up the joints, we can get the gas out much easier. So the green lines are the reopening of the joints, and the whole idea in refracturing, hydraulically refracturing, is to create a network of interconnected pre-existing joints that you have reopened and propped open by sand, and each one of those joints becomes a superhighway for gas migration back to the red line, which is your production casing, and up it goes to the surface and to your gas stove and gas heater. Okay? So we needed to have directional drilling to get that line horizontal. We needed to have high volumes because we have to inject a lot of fluid to open up, reopen thousands of joints. We had to get that fluid down there relatively quickly at very high pressure in a narrow pipe, which means we had to make the water slick. That's where the chemistry came in. And now we can do this again and again. The next well will be a couple hundred feet away from this one in this direction. The next well will be a couple hundred feet away from this one in this direction, roughly parallel. All of them in Pennsylvania and New York going roughly northwest and roughly southeast. Okay. So this is a table taken out of the New York State Supplemental Generic Environmental Impact Statement, which is our rule of the road in New York for how a gas company can operate, drill, frack, and operate a gas well. And it compiles all the interesting historical data, and it says, let's see, first horizontal well drilled in the Barnett Shale, 1991. Slick water fracturing fluids invented, 1996. Multi-stage slick water fracturing of horizontal wells, 2002. Use of multi-well pads and cluster drilling right here in Pennsylvania and down in Texas in 2007. So, as my colleague Terry has said, this is my favorite quote from Terry. He and I get on this one. He said that you realize that in Pennsylvania, the DEP as recently as spring 2008 did not have a strategy for dealing with gas production from the Marcellus. And industry has to experiment to get it right. But I thought the myth was that fracking is a 60-year-old technology that's well proven and safe and didn't need more experiments. So you can't have it both ways. You were told 4 years ago not to worry. This industry is mature and safe. We've been doing it this way for 60 years. They still tell us the same thing in New York. What are you worried about? It's fracking 60 years old, been done on 1 million wells. It hasn't been done this way. Fewer than 20,000 wells have been unconventionally stimulated in shale formations. All right, so the myth is fracking for gas development is 60-year-old well-proven technology. The truth is unconventional development of gas using high-volume slickwater fracking from long laterals is not a 60-year-old well-proven technology. It's about a 10-year-old technology that still is being developed. If it wasn't still under development, you wouldn't have the problems you're seeing.